Today we're going to be welding a 2F or horizontal T-joint with a fillet weld. We're going to be using the Miller XMT 304 machine. It's one of the older machines in the shop, so it's good to know how to use it. So first step, find the on switch. They're usually around this area on the lower, on the actual machine itself. So go ahead and flip that on. Gotta wait for it to come on. It'll show that we're at 23 volts, which is where we want to be for the fillet weld. So don't have to change that at all. Wire speed, also where we want it, but if you need to change it, it's right here. It's this knob. This is in 75 increments, or 75 inch per minute increments. So that's where we want it. Alright, and so this is the actual wire feeder for the machine. Look under the hood, you see that we've got the wire rollers here. They're knurled for the Flux core wire. This is 045 Flux core wire that we're going to be using. And then your spool is under here. Alright, so I'm going to be cleaning off this metal because you want to clean off all the dirt and mill scale to make sure the arc gets good penetration.
After you are done grinding, this is what you should have left. The metal should be very shiny compared to how the metal was very dark and gray on this side. This over here allows for better penetration when you are welding.
Alright, so I've got the T-joint we're going to weld all tacked together, just a little tack on each side. You can see there is a little bit of porosity on this tack because I did forget to turn on our gas up here. Make sure, so this is off. Make sure it's turned on, otherwise your weld is it's not going to be good. So yeah, we got the T-joint set up, gas turned on, so everything is right. We also have our ground hooked up to the table itself. That is going to give us the clearest circuit. You could have it anywhere really connected to the table, but it's best to have it as close to the piece as possible, if not on the piece. Alright, today we're gonna weld with a 1/4 inch plate. That's what we made a T-joint out of. Then what's really good to have when you're welding is 3 points of contact. And what that means is you lean up against something to keep yourself from swaying back and forth when you're welding. You might think that you won't do it, but you will. So get yourself nice and comfortable. Comfortability is key because if you're not that comfortable, you're going to focus on how you're not comfortable, and that's going to take focus away from your weld. So make sure you're nice and comfortable. Then find a good place for your hands in the gun. Make sure that's comfortable, and then you want to do a dry run where you're not going to weld at all. You just drag it across to make sure you don't catch on anything like that could end up messing up your weld. So you want to drag it across, make sure that's nice and smooth. You got a little bit. All right. So yeah, that's pretty good. You get that right there. I'm putting most of my weight on my back foot and on my back against the sheet rock here. And then I'm going to start from the right and drag to the left. Okay, so there are many different types of welding techniques out there. I'm going to be doing what I call the zigzag technique and also the circle technique. The zigzag is where you have the gun where you're going to weld, and you kind of just zigzag from top to bottom going along the weld piece like that. Circles is where you do little circles while you're going down. Circles is not a good idea for this type of welding because you'll be circling back over the weld that has slag on it, and that creates slag inclusions, which is no good.
Completed weld should look like after it's been cleaned and all the slag has been taken off.
Alright, so here we have some examples of what not to do. Right here, this one is an example of welding without any shielding gas. You can see that it's kind of, well, super rough. It just didn't work. Next one, what was this one again?
Stick out.
Oh yeah, so this one we have a very long stick out, or just too long of a stick out. It actually looks kind of normal, but it's bad. So the next one, I did it again with an even longer stick out to more emphasize how bad it is. And you can see it's really ropey. All these little whiskers came out of it because it just didn't have good contact at all, and they just kind of fell off. Then this one right here, wire brush. This one right here was too low a voltage. It just took a very long time to actually melt and bite into the metal. Yeah, too low a voltage.